of a model. The purpose of a model is to explain the variability of the observations. By making a prediction, you try to explain how the observations vary. Therefore, the error of the model, difference between simulation and observation, should be lower in magnitude with respect, in absolute value, with respect to the variability of the observation. So the rationale is, let's compare the variability of the model error with the variability of the observations. Okay? Now, if the model error is 0, it means that you explain all the variability, and therefore the efficiency is 1, because the second term vanishes. If the model error has the same variability of the observations, it means that your model is useless, and therefore this ratio would be unity, and the efficiency would be 0. It's clear? If it's not, please let me know. And your doubt on the IMOD was resolved. I'm not sure. He's not listening to me, but your doubt on the IMOD was resolved. Okay.
Just a question.
Yeah.
Okay. Coming back to the IMOD and to the equation in particular, I didn't really understand the difference between river flow and volume of river discharge. I mean, one should be the integral of the other, but if I got it right, because if I integrate that function fc in the C, then I get the surface runoff.
Yeah.
Okay. That is my because I brought that is not the cumulative volume of river discharge.
Okay, let me better explain. First of all, your question is well motivated because I think that I used the terms in a not very rigorous way. At least I used some synonyms for. So I used the river. I used surface runoff production. I used surface runoff and then river runoff and river discharge. So basically, it's better if I clarify the meaning of these terms once again. And basically, when you integrate this relationship here, and you know, what do you estimate basically? Basically, you estimate through some developments for a given value of C, you estimate what is the volume of water that was stored in the catchment. And therefore, by taking the difference with respect to rainfall, you can estimate what is the volume of water that was not stored in the catchment. And this is up to a given time t. Up to a given time t. It's up to a given value of C, but you can relate the value of C to the time t. So up to a certain time t, you can compute the volume of water that was not stored in the catchment since the beginning of time, starting from your simulation. Now, this is volume of water, it's not discharge, because the discharge or river flow or river runoff, I use these terms as synonyms, discharge, river flow, and river runoff. Also the literature uses them as synonyms. It's defined, the river runoff or discharge, it's defined as the volume of water that flows in the river per unit time. So basically, if I want to pass from the volume of water that was not stored in the catchment up to a certain time, the river discharge, I have to make two steps. The first step is bring the water from everywhere in the catchment to the river, and this is done through the reservoirs in IMOD, because this is a kind of routing, flow routing. It means that the flow is routed to the river. This is the step that in IMOD is done through the reservoirs. And the second step is that I have to divide by time. So basically, if I want to estimate I don't remember the symbol that I used to identify the surface runoff, but I think it was ER. At least in the code it is ER. So ER at time t is a volume. Volume of runoff. From at time t from time 0. From time 0. And now the question is, what is Q at time t? Let me use a lower case. What is the volume, the discharge at time t? Basically, what you have to do is first think that we are working at finite differences when we work, because we integrate the model numerically. So basically, what I need to do is to estimate ER at time t plus delta t, and then Q at time t is equal to ER at time t plus delta t minus ER at times t divided by delta t. This is what, basically we work at a daily or hourly time step. In order to estimate the river flow, we get the cumulative runoff at hour 10 minus the cumulative runoff at hour 9 divided by 1 hour, or 3,600 seconds, if it depends on the unit. So this is what is done in the code, and it is explained in the code, but I probably, when I explained IMOD, I put a lot of attention on the computation of the cumulative volume, and then probably I assumed I was very quick on the computation of the river discharge. But here there is also the routing process in between. Okay? Yeah. Any more questions? Okay, so I go, give me a couple of minutes, I go to the cafeteria, and please feel free to join. I will be very pleased. Okay. Give me a couple of minutes that I need to pack my stuff.